Okay, let's see if I'm on live. Hello, hello. Not sure if this is on live right now. Okay, probably it is. Hello, hello. This is Junichiro Horikawa. This is a live stream for Houdini tutorial. Houdini tutorial live. 133rd episode. It's been a while since I last did this tutorial live series. Been a bit busy because of some schoolwork and all the projects that I had. Well, now I have got some time, so I would like to resume doing this live stream series again. Right? Hopefully I'll be able to continue this from now on. Now, let me know if you can hear me. If you can hear my voice, that will be great. Okay, hopefully you could hear me. So let's start the live stream for today. So the topic for today is, as you can see, I am going to create a procedural spherical gear system, which you could use to create a any input geometry based spherical gear, which you can also change the shape to different stuff, like this one, pig head, or a bit more ordinary shape like this shape. Or you could also go to a spherical gear like this one. So all is based on this spherical gear. So what I'm going to create is this specific spherical gear out of some specific geometry, then trim out this with any input geometry you want. So it's pretty simple, and the geometry that I'm going to be using in order to create this gear is coming from the idea which I saw in this paper called Design and Modeling of Spherical Shaped Gear Arrangement in Kinematic Sculptures, which shows the basic idea which shape could be used to create this kind of spherical gear. Now it says you cannot use a shape like the soccer ball when you have a connection between the gears. If you have a loop of odd number gears, you'll be having a conflict at some point which you cannot rotate, at some point. If you, for example, for this one, if you rotate this gear counterclockwise, then it has to go. If you rotate this clockwise, then it has to rotate this one counterclockwise, clockwise, counterclockwise. And next step, you have to make this rotate clockwise, but it's already being rotated counterclockwise. So you have some conflicts here. So in order to enable having a spherical gear to be able to rotate it, you have to have a even number connections between even number loops even number connections of loops for the gear. So you have to have something like 4, 6, 8, 10 connections in one loop. So this paper shows two example shape which can be used to pick up even number loops. One is this truncated cubocutahedron gear shape, which you have a collection of hexagons, squares, and octagons, which is everything is made up with even number shapes. And because of that, you could pick a even number connections for gears. For example, if you place the gear in the center of a hexagon and a octagon, you will have 1, 2, 3, 4 connections in one loop. In those cases, you have to skip placing gear on squares. If you place hexagon and squares, the gears, then you have 1, 2, 3, 4, 5, 6, 8, 7, 8 connections in one loop, which is again an even number. You could also even place the gear on the corner of the polygon. In those cases, you have, in this case, 4 gears here, you have 6 gears here, you have 8 gears here, so it also works. So you can either place the gear on the center of each polygon or each vertices, and either way it works. Another example is using this truncated icosidodecahedron, which is a bit more complex, looks more complex as a base shape. But again, everything is made up with even number polygon. This is a decadon, which has 10 edges. This one is hexagon, this was square. And again, you could pick up any shape to create even number connections in one loop. If you pick hexagon and squares, you get even number connections in one loop. If you pick up decadon and hexagon, you could create even number connections in one loop. So 1, 2, 3, 4. Yeah, in those cases you need to skip squares. And you could also place on each vertices. So that's the basic algorithm. And what I'm going to choose is, in this tutorial, I'm going to choose this one instead of this cubocutahedron gear shape sphere, because this one, it looks pretty easy to create. It's, the angle is 90 degrees for these octagons. This is 45 degrees for the squares. Same for these hexagons. So I think it's pretty straightforward to create this kind of shape. You can just trim out the cube to create this shape pretty easily. So I'm gonna skip this because it looks too easy for me. So I'm going to try to start by creating this shape procedurally. Try to think how I can create this procedurally, then use this as a base to create a final gear, something like this. So in this case, this is replacing square and a decadon to a gear, okay? Or I could either pick hexagon and decadon as a gear instead. So in those cases, you can replace this gear with the gear somewhere around here, which still works. Yeah, still works. Yeah, should work. So that's my plan. So first I'm going to create this truncated icosidodecahedron, then try to create a gear spherically like this, calculating the number of teeth for each gear, then finally trim it out with original input geometry, custom input geometry. So I already have a sample here. So from some shape, I'm going to create this icosidodecahedron shape. Then create a gear like this, calculating the teeth numbers, then finally trim out the shape like this. So that's my plan. Alright, so let's do this from scratch as I always do. Okay, hopefully I do remember how I made it. Alright. Okay, so start. It's been a while since I did the live stream, so hopefully I'll be able to catch up. Okay, so first thing first, let's create a geometry node, and let's think about how I could create this original shape, the base shape. Truncated icosidodecahedron, which is a bit long name to remember. So first thing I want to do is to search this one to see how I could create this. And this is what I got as a result. Truncated icosidodecahedron. So it has a word truncated, so meaning you have to have a original shape before you truncate the shape, which is this one. This is the icosidodecahedron, and by truncate the points, these points, making it square shape, you'll be able to create a icosidodecahedron. But as you can see, if you just truncate the icosidodecahedron, the shape that you have here as a rectangle is not a square, it's just a rectangle. The aspect ratio of the width and height is different. But in order to make it something like this, you cannot just truncate as is. Okay, and this here shows some informations about the angle between the red and blue, blue and yellow, and red and yellow. What should be the angle for each side. Now you could either use these informations to create this shape, which there is already some informations in this page. Design and build a truncated icosidodecahedron using, in this case, Fusion 360, to use these angle information to create this kind of shape based on these angles. But that's also a bit cumbersome to me. I want to make it a bit more simple. So what I'm going to try to do here is using some base shape to transform it into this icosidodecahedron with this square shape here. Now how I do that, what I'm going to try to do is to use one of the platonic solid. I'm going to use a platonic solid node. I'm going to choose a suckable. Okay. And if you look at this, you have a bunch of hexagons and pentagons, right? Now pentagon has 5 sides. Now if you look at the icosidodecahedron that I want, you have 10 sides on this red polygon. You have 6 sides, this is hexagon, and you have 4 sides on a blue one. Now one thing that I thought is maybe I can convert the suckable into this icosidodecahedron by first of all separating all these geometries apart, then increase the number of edges for this hexagon, I mean the pentagon, by multiply by 2, meaning you can add by adding one edge per one additional edge per edge for this pentagon, you'll be able to create a decagon out of pentagon. And since you already have a hexagon here, here, what you want to have is additional squares in between the hexagon, somewhere in between these connections between the hexagon. So if you could create a squares in between the hexagon, and based on those additional squares, you could probably create a decagon as a result, having in between squares between the hexagons. So that's my plan. I would like to first of all trim out all the hexagons, try to make some space between the hexagon to create a square shape, and to make it a aspect ratio of the square to 1:1 for width and height, I should be able to create a decagon in where it used to have a hexagon, I mean the pentagon. Okay, so that's my plan. So how do I do that? First, I would like to get rid of these pentagon first to make it easy to see, which is pretty easy to do, I think. I could either use something like primitive wrangle to just remove the polygon which has 5 edges. So first, count up the number of edges by getting the number of vertices per polygon. By getting prim points at each primitive number. And if the length of points is equal to 5, which is pentagon, I would like to remove it. Okay, remove prim, oops, prim num. Right, so now I've just deleted the pentagon like this, right? Now what I want to do next is to create a gap between all the hexagons so that I can add squares in between it. Okay, so let's see how I could do that. Probably the first thing I need to do is to separate these hexagons apart by making the points unique. Okay, I have a comment from John Doerr. Separate all the faces, subdivide, bevel, and you should have something. Now, just from the looks of it, it seems like the basic football soccer ball pattern. Let's see. I haven't tried that, so let's see if I could do that. Separate all the faces. I guess you're talking about this one. And subdivide. I haven't tried that one yet. And bevel. It's always good to have some information. I don't know if it worked. Separate all the faces of the bevel. Maybe I'm doing something wrong. But yeah, does look like close to the final shape that I want. Yeah, yeah, it's pretty close. So you have hexagon here, you have a decagon here, if you make these square. So it's pretty close, yeah. So I guess you could transform this into something like this by tweaking the result. What if I do like this? Yeah, it's pretty close. It's pretty close, actually. Without having a unique points, you actually do have a shape that I want here. So if I could just trim out these shape into one decagon shape, I could actually use this. That's good. That's good. Shall we do this? I'm going to make this distance as much as possible, and I could, let's see the patterns that I need to do set. So I want to keep these hexagon, square, and I want to get rid of these shapes. So which is connected to the center pentagon. So I could first look at the pentagon and just remove all the neighbor geometries connected to each points of this pentagon. Then you could just trim out all these shapes, which sounds pretty easy to do. So I'm gonna use primitive wrangle. Yeah, that's much easier. Thank you. Thank you for the information. So, same as what I did previously, I'm going to search for the pentagon shape here. Now, if you are a pentagon, you are going to remove yourself, but as well as removing all the neighbor polygons, which is connected to each points. So I'm going to use the for loop. Oops. I get the neighbor associated polygon primitives of this point. So point prims. Now again, I'm going to have another loop through all these primitives. Then remove all these primitive. Alright. So, did I get it? Doesn't seem so. Maybe after I did the bevel, I might need to do the fuse. Alright, that'll do the job. Okay, so this seems like what I wanted. Now, if I use a something like divide node to remove shared edges, you can get decagon. Make this reversed and merge it with this shape here. You get these shape pretty easily. It's much easier than I thought. Thank you for the information. Let's see. So the necessary condition is that all edges have same lengths here for the hexagon and squares and decagon. So let's check that. I'm going to convert each edge to a line, not this one. Convert line. Check the edge lengths, and every edge length has to be the same length in order for this one to work. Now I do have some gap between the edge lengths. So you have the minimum 0.22, maximum 0.23 might be the same after I did the bevel. Oops. No. After removing edges, we need to do another fuse here. Yeah, there are some maybe it's due to the level of the efficiency or the detail precisions of this bevel, poly bevel. Hopefully I'll be able to make it a bit more precise in order to make these numbers as much as possible to make it equal. I'm not sure if I can do that. Well, if you want to make it precise, maybe I might need to choose another way, but this looks pretty even, so maybe I can go with it to see. If it doesn't work, then maybe I can try another way later. Yeah, probably I don't have some options to make it precise for this bevel or the subdivisions. Maybe I can choose another method. See if I can change any. Nope, still this is a bit closer. This is a bit further. So each one has different precisions. Some might work better, some might not work better. Maybe mantra compatible Catmull clack is best in this case. Smallest gap. So I'll try with these one. Maybe a small difference might not be a problem in this case. So, but if it does, then I can always come back to make a bit more. I can make more precise shapes mathematically. Alright, so let's try doing this first, because this is easier to use. Okay, I'm going to make this grouped, and let's continue to the next step. So now that I have this truncated shape, next thing I would like to do is to create a base gear shape out of picked geometry. Now, as I said, you could either pick a position at the vertex or pick two types of polygons, either decagon and square, square and hexagon, or hexagon and decagon. So and the most packed gear shape in this case is picking up decagon and hexagon. So in this case I'm going to pick these two shape together, or you could either use vertices as well, but that's the least packed geometry in this case. So but in those cases you can use the same gear size which is related to the edge size. Well, everything is related to the edge size, but in this case I'm going to try to use a decagon and hexagon. But maybe I can parametrically choose which one to use. That's what's procedural for, I guess. Alright, so let's do that way. So let's create a new node which I can have a parameter to choose which polygon is going to be used for gear. Okay, so you have three types in this geometry: square, hexagon, and decagon. And you want to choose two types out of it. So in those cases you have 1, 2, and 3 choices out of the pair. So I could create an integer value which can be called as pair, and the range could be in between 0 to 2, so you have 3 options. Or make it a bit more visually easy to see, you could make this as a ordered menu, right? And so that you can name the menu item for each choice. So in this case 4 and 6, which is square and hexagon. If it's 1, you could say 4 and 10, which is square and decagon. And for the third options you could say 6 and decagon. Right. Right, so you have these options. Now let's copy this value and use it to pick specific geometry you want. So let's create a primitive wrangle. Say remove unnecessary polygon and get the value, the channel parameter value that I have set, which is pair information. Let's link it with the null node. Currently it's 0. So if it's equal to 0, then the pair is in between square and hexagon, so I want to delete the decagon. So based on the number of points, I'm going to decide which primitive is going to be deleted, meaning I need to count up the number of edges. So prim points number of edge So if the pair is equal to 0 and if the number edge is equal to 10, you can remove the polygon. Right? So if you have square and hexagon, you're going to have these connections as a gear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 connections in one loop, which is pretty long as a gear, so maybe it's hard to rotate. Now, else if pair is equal to 1, which in this case you are having connection between square and decagon, those cases you want to remove the hexagon. So if the number of edges equal to 6, you're going to remove that like this. And finally, else you could remove the square if it's on the third options. Oop. Maybe I have, this has to be 6. Okay, so now I can choose which one to use for the gear coordination. Okay, and for each of them I'm going to use the center of the polygon as the center of the gear. Alright. Okay. So next I'm going to finally convert this each polygon into a gear geometry. Okay. So in order to make it as a gear geometry, you need to specify a number of teeth. Right. So if you have, let's say if you have a hexagon or decagon, in this case, let's make this simpler. If you have a hexagon and square and you want to convert it into a circle like that, and you want to add a gear, teeth, to make it as a gear. And the important thing is that you have to have a connection between, when you have a connections between the edges, the gear has to match up. You don't want to have a gear something intersected together, but you want to have a gear something like that. In order to do that, you need to know how many teeth you have per edge. Okay, and it's pretty easy to control because in this case you have a good conditions, which is that each edge length is same. There are some gaps in the numbers, as you saw last time when I calculated, but if you assume that the all edge length is the same, then you could easily set up the number of teeth per edge for the gear. So if you have square and hexagon, and let's say if you divide one edge by 5, 1, 2, 3, 4, 5. In this case, for the hexagon, you could create a gear having this wave. And for the square, you could also create a wavy square in a same manner. You can do the same for each edge because you always have same numbers. If you have 5, you have 5, 5, 5, 5. Right. And actually, the divisions have to be even number if you want to connect between the edge and the next edge in order to have a continuous wave or a continuous teeth. So it has to be from 2, 4, 6, 8, 10, and so on. You actually cannot use odd number if you want to have a clean connections between the edges. Okay, so you could just decide an even number for one edge, then you could that will create a total number of teeth. You can estimate the total number of teeth out of it. If you have 6 edges, then that will be 6 edge multiplied by the number of teeth. If you choose 8, that will be 48. If you have a square, that means 4 edges by 8 and 32. Okay. And you are sharing the same number equals to 8. So you could always divide the gear teeth number by 8. And so you could use these numbers to estimate how many frames you need in order to create one rotations. This is not going to be 360 degrees, but you might need several times to create one completed rotation, which will be going to be important when you're going to choose custom geometry in order to rotate. You want to go from one shape, rotate it customly, then going back to the original shape by rotating at some angle. And to do that, you need to know how many teeth you have per edges. Okay, that I'll come back to this later. Now, so thing that I need to do is to choose a number of edge, number of teeth to divide per edge. Let's do that. Okay. Also, just as an information, I'm going to apply an attribute to each primitive number of edge, just in case I might need it sometime. Right. Okay, so to have a divisions, to have a number of divisions for each edge, I could use a node like resample. Okay, and the important thing is to check this box, resample by polygon edge, which will resample per edge. Okay, and also disable this maximum segment length here. Then instead check the maximum segments. This will define how many divisions you'll get per edge. So if you say 2, you are going to have 2 edges here, going to have 2 divisions, meaning you're going to have 2 teeth, one for the mountain, one for the valley. And if you make it 3, then you're going to have a problem connections to the next one. You're going to have mountain, valley, mountain, and the next one is going to be again a mountain. So as I said, you cannot use odd numbers. You have to have an even number for these divisions. Mountain, valley, mountain, valley, mountain, valley, mountain, valley, so on. So let's have this as a parameter again. Number of teeth per edge. Okay, and I don't think you can set a even number for the input, so I'm going to convert any input number into a even number in the expression or in the VEX code. Let's say I can set from 2 to 20. Maybe 20 is a bit too much. 2 to 10. So the minimum is 2, maximum is 10. I don't want to be able to choose 3, 5, or 7. So if I got 3 or if I got 5, I need to convert it into some even number. Let's do that in a VEX code. Okay, or maybe I can do this in this resample node here under the segment. using expression. So first I can just paste the value here, which is currently 5. So in order to make this even number, there are several ways, but one thing I could do is to first of all multiply by 0.5 and make this integer by using something like rint or seal. Maybe I'll just use seal. Then multiply by 2, which will convert. Since I'm multiplying by 2, it always gives you an even number, and and by multiplying by 0.5 it will make it as small as half number or a little bit bigger than half number, but it's always going to be integer because of this kind of function. Then you're going to always be having a even number which is close to the original number, in this case 5. Okay, if you set this to 3, it becomes 4. Right, simple expression, but the even number is guaranteed. Now right now the problem is the shape is a bit too, how do I say, squared or too straight. I mean, doesn't really look like a gear shape, but it's pretty much original hexagon. It's pretty much a decagon shape, but I want to make it as a circle shape to make it look more like a gear, which is like this one. I want to make it a circular shape. So to do that, you could still use a resample node, but instead of using 3 polygon as straight edges, you could change this to either subdivision curve or interpolating curve. If I change this to subdivision curve, it actually create a circular shape, which looks pretty good, and it does have some gaps here, but I can always scale it up later to fill them. So I think using this one is fine, and it still keeps the number of segments. Even if it looks like circle, the number of segment is the same. So using either subdivision or interpolation curve looks good to me. I mean, that's the easy solutions in this case. Right, now that's that. Now next thing that I want to do is to count how many total teeth number you have for each polygon, which is equal to a number of points. So I'm going to count up how many points I have for each polygon, which will become the number of teeth, and which has to be a even number because of these conditions. Okay. So let's do that by first of all use fuse. Oops. Just in case I don't have a duplicate points on same positions. Then use a primitive wrangle to calculate the number of, what was it, teeth. So again, the number of teeth, I'm going to use a prim points, get the number of points per primitive, then calculate the lengths. Alright, let's check. Going to primitive, so the number of teeth, you get 24 for hexagon, 40 for decagon. Alright, that's good. Okay, now next thing I would like to do is to fit the circle into original shape. If it's hexagon, then I want to fit this subdivided or circular shape to fit inside this hexagon so that the edge of the circle touches the edge as much as possible. Okay, which I could do that by calculating the radius of the current circle and also calculate the projected length to the edge of this hexagon from the center, then use some scale value to fit. Yeah, you could either use for each loop, for each node, or you could just do it in one wrangle. I'm just gonna use wrangle for this. So point wrangle, I'm going to do the processing for each point for the circle, and I would need the guide. I would need the edge informations, so in order to calculate the distance to these edge from the center of the circle. So let's convert this into line. Now the reason why I'm not seeing some of the edges because I'm having a color attribute which is at some point is black, maybe. Yeah, there are black point which hides the edges, so let's delete the point color information. Attribute delete. I'm going to delete the color, maybe a primitive as well. Okay, this should solve the hidden edge problem. Okay, now going to connect this to the second input to this point wrangle. Okay. Okay, so let's try to fit the circle to original polygon. First thing first, I'm going to get the radius of each circle. Now I'm looking at the points right now, so I need to get the associated primitive of this point. Circle is point prims. I think each point only associated with one polygon, so you could always say like this: get the list of primitives from this specific point number, then just get the first one. Now from this circle I can get the center by looking at the p attribute of this primitive, which is going to be the center of the circle, which means I can now calculate the radius by calculate the distance between the current point position and the center. Now this is the current radius. Now I need to know the target radius. The target radius is, you can calculate it by projecting the center to the edge, which is this one. So you could use something like XYZ distance to the edge from the center. This should be the target radius. Now I have the target radius and the current radius. I can now calculate a scale value by dividing target radius by current radius. Then use this to scale the position. Scale each positions. Now the center of the position, center of the scale is center attribute, variable. So first I can move each point to make the center origin. Scale up this p value by scale variable, then may move this back to the original positions. Spell mistake. Now it's been scaled up to fit as much as possible to the original polygon. There might be some gap because, as you see previously, that there are some edge lengths differences in between each edges, but I think it's pretty close to the fit shape. Let's check that. So it's good enough, good enough. Yeah, everything is good enough, I think. It's pretty much touching to the edge as much as possible. So in terms of the precisions, this is pretty much good enough for visualizations. If you are creating things for production, for fabrication, maybe you want to make it more precise, but in this case it's fine. Right. Looks good. Now that I have it, it's time to create a actual teeth on each edge of these circle. So if you again visualize the points on the circle, these each edges represents one teeth. One could be mountain, and the next one could be valley, and one could be mountain, and the next one will be valley. Okay. So that's what I would like to do, right? And the in this setup, you have two types of polygon. One coming from the decagon, one coming from the hexagon. And each one is rotating to a different orientation. If decagon rotates clockwise, hexagon must rotate counterclockwise. Okay, so the if you have a circle coming from the hexagon, and if you have a circle coming from the square, and if hexagon based circle rotating to clockwise, then square based circle must rotate in the other rotation orientation. And in terms of the teeth direction, if it's rotating to clockwise, let's say if you have a wave like this, maybe two waves, 1, 2 waves. So if the wave always starts from the left side of the edge, then you're going to have this part. You're going to have the first things always be the mountain for the hexagon. If you look at the square, the left side of the edge will be here if the normal direction is and the same as the hexagon. You're going to have this one. You're going to have a edge point from this one, and if you start the mountain, then like this, I think will fit with the neighbor teeth mountains. Now I'm not sure if that's true, but let's check that out. If it doesn't work, if it's collide with the next one, then maybe I can make a condition, either if it's hexagon, either if it's decagon, to change the direction or the angle of the wave, or shift the angle of the wave based on the type of the polygon, which way it rotates, clockwise or counterclockwise. Okay, so let's do that. Now I want to make it procedurally as much as possible, so let's look at the information that I have in the primitive. Currently I have a attribute called numEdge, which represents the number of edges, which in this case I have 6 and 10. So I think I want to get the either minimum or maximum of all these numbers so that I can use it to see, because I only have two types. If I know what's the maximum out of all the number edges, then I can define which one could rotate clockwise and which one should rotate counterclockwise. So I'm going to use an attribute promote to get the maximum of the num edges to detail. Max num edges. Prim num, okay. Maybe. Okay, so max num edge 10. Okay, so maybe I could use this to define which should rotate clockwise. So if the number of edges is equal to maximum, maybe I can rotate it clockwise direction. Okay, and based on these information, maybe I could change the the angle for the teeth. Let's see. So in order to create a teeth per edge, what I need to do is to create additional points per edge to create a mountain, both for the valley and the mountain. Now if you look at the books where it shows how you could create a gear shape, you seem to have a specific angles, or you seem to have a specific shape for the gear in order to make it as smooth as possible to rotate. But in this case I want to make it simpler, so I'm just going to use a sine wave. You can replace that with a more sophisticated one later if you want, but in this case just want to use a simple one, so let's make it a sine wave. So in order to use a sine wave, you need to have an angle to create a wave shape. So one edge represents 180-degree wave, which is either mountain or valley, and two edge represents one full wave, 360 degrees. And so based on those informations, let's try to create a wave for each primitive. Now you could either use detail wrangle or primitive wrangle, but I'm just going to use a primitive wrangle to do that. First, I need to get the edge information, so let's get all the points on the primitive. Then loop through all the points. Each I represents the number of edge. If its I is equal to 0, maybe this is the first edge, this is the second edge. So I represents the number of edge. Okay. Now since we are looking and we want to look at the edge, you need to have a neighbor points. So if you get the first point, you need to have a next point as a edge information. So I'm going to get add I plus 1, and there is a chance that it's go back to 0 at the end, so calculate the modulus. with the length of PTS. So if this I is the last number of the point number, then the next one should be 0. So this is why I need to have a modulus here. Okay, now that I have 2 points, in order to create a wave shape, I need to have these position information. So convert this into a position. Alright, then need to decide how many divisions you want to have in order to create one wave. It could be any numbers, but small as possible, but to make it as wave as much as possible. So I'm not sure what's the best number, so let's make it parameter for now. Let's say like 5 for now. And create another loop to create one wavy shape. This time I'm going to use a variable called n, and now for this one what I need to do is to calculate the angle for the sine wave, right? And based on if the edge is on the even number or odd number, it needs to change the edge. It needs to shift the angle by 180 degrees. Let's say if the edge is at the even number, I want to make it as a mountain. In those cases, for the odd number edge, you need to make it a valley. Okay, so for the mountain, the angle ranges should be in between 0 to 180 degrees. For the valley, should be in between 180 degrees to 360 degrees. Okay, so let's create angle based on those information. So first of all, an angle can be calculated by a current n value by a division. Let's make this float just in case, and multiply by pi. Okay, which will create always in between 0 to 180 degrees for every edge. Now I could try with this first. Okay. Now out of this angle I could create a sine wave value by just applying this angle to the sine wave, which will give you the value in between -1 to 1. Right. Now next thing I want to do is to use this value to create the actual wave position, wave point positions, the point on the wave position. To do that, you might want to have a normal directions for this edge to decide the point positions, right? So as well as in which point should it start, in between the starting point and the end point, in this case position 1 and position 2. Okay, so first thing first, let's calculate the points which is on top of the edge, right? So I'm gonna call this edge position e plus pos. So it should be in between position 1 and position 2. You can estimate the position by using something like lerp between position 1 and position 2 and use a value out of n by normalizing between 0 to 1. Okay, so if the n is equal to 0, you get position 1. If this value is equal to 1, then you get position 2. Alright, now next, before adding a sine wave directional value, I would like to create a point first in order to see if I'm getting the right positions on the edge. So now that I have this edge position, let's create a new point at this E position. Oops, at point 0 E pos. Yeah, so I seem to have 1, 2, 3, 4, 1, 2, 3, 4, 5 per edge. Now, since the previous primitive is no longer usable, so I need to remove the original primitive shape, original circular shape. Now currently I only have points, so next thing I need to do is to connect each point to make it one single primitive. So let's create a gear prim as a polygon. And add this new point to this gear prim. There you go. So seems like there are no problem at this moment. Now that I have each point on the edge, I can now shift these point position to the normal direction to get the sine wave like shape, like teeth like shape, which I could calculate somewhere around here. Okay, so currently I have a E position which represent each point on the edge. So I can calculate the normal direction by probably subtracting this current edge by the center of the sphere, which will give you a perpendicular direction for each point. So let's make that. Normal is E pos minus, the center is at P, because we are originally looking at each primitive. And let's normalize it. Okay, now that I have this direction, I can then update the E position by the normal multiplied by the lengths of the teeth. Right, and together with the sine value, which gives you the information whether it goes to the mountain direction or the valley direction. Currently it only goes to the mountain directions because of this condition, but let's see how it goes. Okay, now let's promote this teeth length and increase the value. Let's see what happens. Now I could see that it collides, but everything goes to the mountain direction, so that's a problem. As I said, if the edge number is even, I wanna make it mountain. If it's odd number, then I wanna make it value. So I need to change this angle based on the number of edge. In this case, I could use PTI for that, or maybe I for that. I represents the number of edge. So if I is even, you can make a mountain. If I is odd, then you can make a valley. So if I calculate the modulus with 2 is equal to 1, meaning if it's even number, then you can add angle by 100, additional 180 degrees, which will give you a shift to 180 degrees for the odd numbers. And Then now you could have a mountain for the first edge, a valley for the second edge, mountain for the third, uh, valley for the fourth. And now it all looks good. You don't have a problem with the intersections anymore, collisions anymore. Now let's try changing the number of divisions here. Yeah, it just gives you the resolutions of the gear. Maybe 5 is good enough, 4 or 5. Let's make it 5. And also going back to the controller, changing the number of teeth per edge. You could see you can change the number of edge here, number of teeth here. It's still having no collisions in between all the gears. Looks good. Alright. So for the moment looks good, and well, right now it's all being placed flat on each position. So next thing I want to do is to make it spherical, project it to a sphere after this. So let's first of all calculate the normal, just to make sure I have a clean normal information for each primitive. Okay, let's group this, and you could also check if it works on the other conditions. Currently I was testing with 610. If I make this to 410, still looks good. If I make this to 4.6, still looks good. Yeah. So everything looks great here. I'll go with this for testing. Okay. Thank you for Matsutake-san for the super chat. Thank you very much for the kind words. Thank you everybody for coming. It's been a long time from the last time I joined. I did the live stream. I'll try to make it consistent as much as possible for now on. Yeah, I was a bit busy with the work at the school and so on. Where was I? So I wanted to project this to a sphere, and later I want to trim this out with the custom geometry. So to do that, you need to have a bunch of edges to project this. So I'm going to do the remesh here, and make the target size something like 0.05. I mean, it doesn't really matter what's the best thing. If you want to have a high detail one, you can make it lower. If you're okay with the lower detail, you could say 0.1 and so on. I'll go with 0.05 and make it smooth as possible. Alright, now let's project this to a sphere. I'm gonna create a single sphere, or maybe I can just use the point wrangle as is and make circle. I make a sphere, make each point projected to a sphere radius of 1. In those cases, I could just do it mathematically. It's pretty easy. So you just need to have a normal direction for each point, which can be calculated as normalized point positions, and you can just replace the point with the normal, and that's it. There you go. Was easy. Now next I want to try rotating this gear, okay? And because since this is a gear, I need to rotate it anyway. So which is pretty easy because you already have necessary informations in order to rotate it, which is a number of teeth per edge, which could be used how much you need to rotate per polygon. The speed of the rotation should be different between the hexagon based one and decagon based one. The speed should be related to the total number of teeth. Okay, if the number of teeth is larger, then the speed of rotation is smaller. If the number of teeth is small, then the speed should be larger. Okay, so because you are dividing 360 degrees by the number of teeth, and that will be the step angle value for each rotation. Okay. Oh, I'll just do it with the code. So before making it with the custom geometry, I'm just going to try to rotate this to see if I can get the seemingly correct rotational representation. I'm going to use a pointer angle for that. Okay, and connect this to here. Now, in order to rotate each gear, you need to have a center of the rotation as well as the axis and the angle. Okay, the center is pretty straightforward. You can get the center from the original shape, which is this one. I think it's better to get the center from the original polygon, which is the most precise informations. After you do the subdivisions and fitting, there might be some offset in those processes. So I think it's a best bet to get the best center point information from the original positions, original polygons. So I'm going to trying to get the center point from this polygon. I mean, it could also be coming from the fitted circle. It's your choice. It could be coming from here as well. I guess either way works fine. Then next, I think it's more or less expensive to calculate from less number of edges, so I'll just choose this one. And next, the axis. Axis is the normal direction of each polygon, which I already have it right here. Right? For each primitive, I have these normal information here. So that could be the axis, the rotational axis. So I can connect it here. Now finally, the angle. The angle can be calculated from the number of teeth, right? Which I should have it on some part. This currently is 0, so not good. What's this? This was okay. This is creating a gear teeth. So right here I had number of edges and number of teeth, which was removed after creating a gear. So I could either refer to this information or transfer the attribute to the new gear. Maybe I'll just transfer it. Sometimes attribute transfer doesn't really work well, but let's see if I can do that. I only want to transfer the primitive attribute, just transfer everything, and seems like it's it's been projected correctly, so maybe I can use this. Okay, so I can have this number of teeth information from the third input. Okay, so let's gather all these informations. First of all, the center. Is from the second input. Oops. Wait a minute. Since I'm working with each point, I need to know the associated primitive number for that. Right. So let's get the primitive number first. Point prims 0, and then I could get the center information from the second input. I could also get the number of teeth from the third input, as well as the normal information from, again, the second input. Alright, so I have those three information. Maybe I can say it as axis. So I have center, number of teeth, and axis. Now I want to convert this number of teeth to a angle value. Okay, what I could do is to simply divide pi multiplied by 2 by the number of teeth, which will give you a step angle per tooth. One tooth. And by multiplying by value less than 1, you could have some small movement, small steps for a step tooth. If you say 0.25, you're going to use 4 frames to rotate one teeth. Yeah, one tooth. Okay, now that I have those informations, it's time I can create the rotational matrix. First, creating identity matrix, rotate this identity matrix by the angle multiplied by current frame to make it as an animation. Then axis. Alright. Then apply this rotation to each point by first of all subtracting the point by the center, so the center become the origin of the rotation. Apply the rotation matrix to the point, then make this back to the original position, original center. Okay, let's see. Now, and one thing I forgot to do is to make either one of the polygon type to rotate clockwise and either one of the other types to rotate counterclockwise. Currently everything rotates to the same orientation, and what's happening here? Okay, I think I'm doing something wrong here. Let's fix this. Let's reset the viewport. Okay, interesting. Maybe I'm doing something wrong here. So I have, wait a minute. Okay, sorry. I cannot use a primitive number from here because it's remeshed. Doesn't gives you the information that I need. What I need is the original primitive number, which used to be 32 primitives. So before doing the remesh, I need to preserve these primitive number for each mesh or each point. So I guess without before doing the remesh, I need to have a primitive number information to each point. Let's name this prim_n, which derives from the point prims. Okay, so this information should be in between 0 to 31. Let's check. So 0 to 31, and if I do the remesh, I want this to be preserved. Did it? I'm not sure. Need to check this out. So after doing the remesh, gotta check whether this prim_num is for each primitive. Nope. The one that's inside the primitive is not related to the primitive number, so well, in those cases maybe this doesn't mean anything. I need to project or transfer the attribute from this to this after doing the remesh. So I'll do this here. So in this case, I'm looking at each point on the remesh geometry, and as I'm having this as a guide before the remeshing. So I can just pick the closest point on the second input for each point on the remesh. So I can use a function like xyz distance which give you a closest primitive number on specific input number, which in this case second input. And that's the information I want to have. So prim_n is equal to prim. Now if I check it, point random on attribute prim_n, there you go. Alright, so this will give you information that I need. Now let's connect this input to here. Actually, I don't really need this. It could still go here. What I just need is to get this value from prim_n attribute, point attribute. Okay. Other than that, I think it's fine. Yeah, let's see. Alright, so the problem here now is that everything is rotating counterclockwise, so you are having a collisions here. So if the decagon based gear is rotating counterclockwise, then hexagon based one has to rotate in a different orientation, clockwise. So that's where you're going to use the conditions whether it's is equal to a max num edge or not for the num edge. Now, do I have this information after the remesh? That's the question. So I have it right here. Actually, I already got that number. I mean, I could get the number right here. prim2 as well as a max num edge. Alright, so and this information is going to be used to decide the angle. If num edge, current number of edges is equal to the max number of edge, in this case dodecahedron, I mean decagon, then maybe I can make the angle clockwise by multiplying by -1. And that's all you need, I think. Let's see. Nope. Still not. Maybe I'm doing something wrong here. Let's check if I'm getting the right value. So 0, 1, 2. So the primitive right here should have the primitive attribute num edge. Yeah. If I look at the detail, I do have max num edge. Do I have a wait, this is wrong. The name is max num edge. There you go. Now let's check again. Oop, still not correct. I think wait a minute. Why am I having primitive here? I need to check if I'm getting the right value. Looking at the point, yeah, I'm getting 10. Okay, that's good. Wait a minute. Yeah, and am I getting this value correct? Seems, yeah. Alright. Oh, forgot to uncomment this. Okay, hopefully this works. There you go. So now it's pretty fast. Seems to rotate just fine. Okay, looks good. Good. All right. Now currently it's all spherical, so you don't really need to set the loop informations to it. But once you convert this into some custom shape for each gear, you start to have a thinking that you might need to have what's the angle for one loop for this actual gear. Okay, 360 degrees is just for one gear, but if you have multiple gears attached together, you need to have a corresponding angle in order to make one loop for whole gear connections. Okay, but currently you don't know what that means. So next step is to convert this into a custom shape, right? Trim it with a custom shape. Now to do that, first of all, I would like to have some thickness to this gear, right? So, which is pretty easy. You could just have an extrusion to the center for each gear shape. Okay, and for that, I'm going to use a for each node loop. Now I'm not gonna do it after the rotations because that's going to be heavy. Because for each frames you need to recalculate the extrusions. That's not efficient. So I want to make the animations into the last to make it as much efficient as possible for the calculations. So I'm going to create the extrusion somewhere in between the shape and the rotation. So this will be the final step actually. Now let's go to the extrusion part. For each connected piece, I'm going to do some extrusions to the center. Now thing is that I want to keep as much attribute as possible for each point and primitive. So I'm not going to use extrusions because it's not going to create it's not going to preserve a current attribute to the newly created points. So instead, I'm going to use a bit cumbersome but safer way to make a point to extrusion method. So first I'm going to create a transform, scale each surface using 0 as center of the scale, then scale it with some smaller value like 0.2 or 0.5, I'm not sure, let's say 0.3, and add the divide in between this transform and remove shared edges, which will create a outline of this polygon. Okay, and what I'm going to do next is to merge the scaled outline and unscaled outline. I'm going to have things like this. This is the original shape, this is the scale one. Then using skin node to create the side shape like this. It's like a cupcake shape. Now I can have another transform, say having the same scale value. I could use Command Option Shift to drag to create a linked node, sharing all the same values with the original one. I think it's in Windows, it's Control Alt Shift drag. Yep. And connect it to here, which is the original shape without removing the inner edges. Now I can merge the original shape, side, and the scaled to have one closed geometry. Now this one has the different orientation. I might need to reverse it. There you go. Okay, so without using extrusions, you could create a extruded geometry like this. And after I leave the loop, a geometry like this, and hopefully it will work with this rotational code. There you go. Yeah, since the attribute being preserved, I don't need to really do anything. Okay, that's good. Now that I have this base geometry for the three-dimensional gear, three-dimensional closed gear, it's time you prepare a custom geometry to trim with this, right? So let's do that. So I could just choose anything, test geometry. I'll try with the head, template head, and try to trim this head with this gear geometry. Okay, and you might need to do this inside the loop in order to transfer the attributes. If you do this outside the loop, then it's a bit hard to transfer the attribute, which you'll need to rotate. So I'll do this inside the loop. You could still do it outside the loop, but maybe it's gonna be harder. The downside of doing the trimming inside the loop is that it's a bit much expensive than doing outside, because you have to do the Boolean operation for each gear. Well, in this case you don't have much number of gears, so it should be fine. First thing first, you need to have a closed geometry, you know, if you want to do the Boolean operations. Currently this template head is open surface, so Let's make it closed by using something like polyfill, if it's possible. Okay, seems it worked. Yeah. And next thing, I need to match the size of this head with this sphere, but it needs to be inside the sphere. So, but as big as much as possible. So I'm going to first use a match size to try to fit these head to the gear, to the original gear, which I can refer to the one, something like this one, which is the sphere radius is equal to 1. And I could turn on the scale to fit. Right, so now it fits within the sphere, and maybe I don't want to have these shape going off the sphere, so I might want to scale it down a little bit using transform node. Get the make this something like 0.7. Well, maybe you could parameterize these value later. Let's make it 0.8. Okay, seems good. So it's been covered by the sphere. Now that I have this shape within the sphere, it's time you trim the shape with each gear geometry. This one. Okay, so simply I'll use Boolean for that. It's expensive operations, but I don't know the other way, so let's do that. I'm going to connect the first input with the gear shape, choose the intersect, then connect it with the shape that you want to trim. Did it work? Yeah, I think it worked. So you have trimmed part of the human head with the gear. Now what I need to check is the attribute. Probably for those points, probably for those points which used to belongs to the head doesn't have an attribute that I need, which in this case a prim n. Let's check. So yeah, just as I thought, prim n, sum of this prim n value is equal to 0. But again, prim n is always constant for each gear, so I could just use a attribute transfer to just full copy the any prim n value from the points by checking off the distance threshold for the conditions. Now every point should share the same prim n value. And that should do the job. Let's also check the primitive attribute. So I have number of edge, number of teeth. Do I have that? Num edge, num teeth. No. I need to have that as well. Or do I need it? Maybe not. Maybe not. Maybe I don't need it, but just in case, let's copy that as well. Okay, that should be enough. Okay, now let's check. Let's go back to the rotation and check the final shape. So right now the human head has been trimmed with the gear geometry, and the rotation should also work with the same code. Yeah, if you look closely, you do are having this teeth being biting correctly to each other. So that's good. But now the problem is you don't know what's the angle, the final angle for one total rotations. It's not 360 degrees. It's not that simple. So you need to find out what's the angle for the one single rotation, so it goes back to the original shape. And in order to estimate that, you need to know several informations. And you can go back to where I left off here. So as I said, if you have two different gears with different teeth numbers, let's say the edge divisions is like 6, okay? Each one has 6 teeth, meaning if it's hexagon, you have 36 teeth. If it's square, you have 4 by 6, 24 teeth, okay? And each one could be divided by 6 for obviously, which will give you 4 and 6 and 4, okay? Which you could still divide these two value by 2 to make it 3 and 2, 3 by 2. So you need to find an aspect ratio between the next one for 2 polygons for the number of teeth, okay, or in this case number of edges, right? And you could use these informations to estimate the total, the final angle number value together with the number of divisions per edge, right? So in this case, the one full total angle can be calculated by first of all, you are dividing pi multiplied by 2, which is 360 degrees, by the number of edges, which in this case 6, okay? And then you could then multiply this, and this can be called as step angle, and you could multiply the step angle by this aspect ratio related value, which in this case you can just multiply it by 3 multiplied by 2, okay, which will give you which should give you, and if I wait a minute, if I, and also you might need to wait, might need to do this on the code. It's a bit I'm a bit confused. Okay, so let's check this by writing the code step by step. Okay, so one thing you need is okay, so this is where I need to define the angle, right? So this is gonna isolate this value here. So I'll start with the step angle right here. Okay, so the total 360 degrees divided by number of teeth. This will be the step angle for each primitive, each gear. Okay, and now I need to define the actual rotation value, which goes from original shape to another original shape. Okay, so let's see. Step angle gear segment. Now let's also have this gear. Oop. We're having an earthquake here. Okay, looks fine. Okay, so we need to have a how many teeth you have per edge, so I'm going to copy this value here. Okay, and have it somewhere here. Wait, oh, do we, oh, I already have it. Oops, so I don't really need it to. Sorry, I already have it from the attribute, so that's good. Now, now that I have it, yeah, since this is the one. Wait, is this correct? Number of teeth is the total number of teeth, right? But okay. Wait, what's the difference between the number of teeth and number of edge? Forgot. Let's check. Number of edge, oh right. So number of edge is the actual value that I wanted to use, I think. So this is the divisions per edge. Right. Okay. I'm a bit confused. Okay, so let's see. Let me just increase the number of frames, and let's also multiply this angle by number of edge, and since you have if you have a connection between two polygons, you have two edge numbers. Wait. And next, what was the value to define here? Let me go back to what I have wrote previously. I think there should be a equations for that. Totally lost it. So previous example. So let me go back to right head up. So so currently I have 10 polygon and 6 polygon. right? And I am having some divisions number here, sharing the same divisions number per edge. And so I have 6 by 10 and 6 and 10. And then if I the aspect ratio of this value is 3 by 5, right? And if you multiply 3 by 5, then you get 15. So this is, having this value is important to make one loop, to synchronize loop. Okay. So, and as well as having the number of edges, which in this case, if you have 6, then you can multiply it again, multiply it by 6, and that would work. Let's see if that's the case. Okay, so in this case, angle multiplied by num edge multiplied by the sharing number. So so you need to calculate the aspect ratio somehow between two polygons. Do I have that information currently? I mean, you can derive from these parameters, but let's see. I already have the maximum number, maximum edge, so maybe I can promote the minimum as well for that. So that I have two polygonal informations, minimum, maximum, and I could get that information in this rotation from the third input, from the detail, right? So let's get that, int min num edge detail. I could first try by multiplying these two together, which should still gives you a complete synchronized angle. And multiply by the frame value. Let's say going from the first frame to the end frame, you're going to have one synchronized loop rotation. It might be more than one, but should be going from start to end, hopefully. And let's see if that's true. Hopefully it is. Not sure yet. So it's rotating so much. Maybe it's too much, obviously. So if I go from one first frame to, okay, it's already been having a complete loop at the 13th, so obviously this is too much. So this is not a correct value for sure, so I need to fix that. So so let me go with the hard number for testing. So I have like hexagon and decagon, which aspect ratio is 3 by 5. So in those cases, so now you have 26 frames to finish. Okay. Still not going from 0 to 1, so still have some problem here. What was the okay, so again, what do I need to do next? I think having 3:5 ratio is I'm starting to doubt if this is correct. Do I need this number of edge here? Okay. Okay, look, okay, so this, in this case, this is full loop, 140 some frame. Alright, still not going from 0 to 1, so that's not what I intended to have. What if I don't have these values? What's the actual one, 2, 3, 4, 5. Okay, so when this part rotates 5 times, it gives the whole rotation. Looking at the decagon based gear, let's check. 1, 2, 3, and that's it. Okay, makes sense. So for the decagon rotation, you need to have 3 rotations, and for this one you need to have 5 rotations, which is again based on the aspect ratio. So my calculation was wrong. I can just refer to one of the polygon and decide the actual angle, rotational angle, I guess. So let's say so I do have these values. Let's first get the aspect ratio in integer, shall we? What's the, how do I do that? If it's 6:10, I want to convert it and need to convert that into 3:5. I mean, I could just I need to divide each one of the value by from 1 to 10, 1 to 9. No, 2, no, with the prime numbers. Oh well. Can't think of an algorithm right now. Yeah, I need, if you can just get the prime number out of the value, then that's what you need to do. But for now, my brain is not working well, so let's just assume it that you only have square, hexagon, and decagon, which everyone shares 2 as a prime number for the multiplication, so you can just divide it by 2 for every polygon. So max A is max num edge multiplied by 0.5, and min A is min num edge multiply by 0.5. That's not really smart, but well, for now. So hexagon, square, decagon, yeah, you cannot even divide by 4, so that's the 2 is the only prime number which you can use to divide. Okay, now that you got the aspect ratio, you can pick either one of it to deal with the rotation, right? So you have the primitive number, you have the teeth number, you have the number edge. So based on the number of edge, okay, if number of edge is equal to the max num edge, you want to use this minimum a value as a guide for the total number of rotation per loop. I mean from 0 to 1. So the angle, let's give the angle variable here, and the angle is minimum a multiplied by pi multiplied by 2. That's the full rotation, multiplied by the frame based value, which in this case, this one. So let's have it as f else. The angle is maximum a multiplied by pi multiplied by 2.0 multiplied by f. Now let's see if this works. I think it's rotating too much, obviously. That is because am I doing something wrong here? One, two, three. Okay, it's rotating too much. I only want to rotate this 5 times, but it's rotating too much. 1. Okay, why is that? So what if I do it like this? Does it still give? Oh wait, I'll have frame here. Damn it. Maybe that was the whole reason why it didn't work. Shoot. Well. Oh, maybe in this case 1, 2, 3, 4, and 5. Okay, now it looks good. So for the hexagon, it's rotating 5 times. For the decagon, it's rotating 3 times. And at the end, it synchronizes to the final shape, the original shape. Okay, that wasn't really smart. There must be better way to write this up for sure, especially this part. I don't really like it, but at least it should work for this setup. If I change this to 410 square and decagon, hopefully it still works. Yep. What is this? What is this? Oh, where does this come from? It is coming from... maybe the rotation isn't working very well. Huh. Some point is having some problem. Oh. Seems like it's been fused. Maybe the point it was too close to each other. That might be the reasons. So maybe the problem is somewhere here. Maybe. Yeah, probably these are the maybe it's touching each other. This might give some errors. It's pretty okay, this part. Probably due to some attributes issue here. Let's see. I'm gonna fix this and probably I'll finish this live stream after that. Okay, does this work? Okay. Does this work? Okay, this one has some problem here. Huh. Well, let's see why. So, checking at the deformed points. There must be some issues with the point attributes. So it says the primitive number is 35. Everything else is still put it 35, so that's sounds good. Huh. Okay. 35 for everything. And this one points delete non-select. Okay, so that's the problem. It's having the different number. It shouldn't have 9, but it should have the same 35, which is supposed to be transferred from by this one. So maybe the original geometry itself has 9. Okay, so that's the problem. So you need to go back here. Yeah, one primitive has 9, so that means you need to go back here and fix where you estimate the primitive number. Okay, so this one was the problem. Right. It's just projecting the points, so maybe it was not good enough to estimate the primitive number. Alright, makes sense. Makes sense. So let's think of a better way. What if I have a primitive attribute called prim number? Can it be preserved after the remesh? Seems like so. So this is more reliable, I guess. And if I could do that, then I can just attribute promote, transfer the attribute from primitive to point. Like this. And this should give you more reliable transferring and no more issues. Okay, that's better. It's better. Alright. There you go. Think I have managed to create a one whole loop for the spherical gear for any input geometry. Alright. Now I could it's time to promote some parameters that I can control, such as these inner gear scale, which can control the thickness of the gear. Okay, so let's promote everything that I can control. So I only have 2 for now. Let's see what else I can give. Nope. Nope. Number of teeth. Fit. This is automatic. This is a resolution. Teeth lengths can be parameter for sure. Divisions, I don't really need to change it, I think. This is the the remesh resolutions can be parameterized, but I'll skip it. It's not really important. Normalize, this is fine. Now I could make these part parametric. Maybe I might want to switch the geometry to something else. Something like big head. Let's see if it works. And yeah, seems to work. Wait. I'm not able to rotate somehow. Let me just reopen this. Right, so it does work for big head as well. It's good. Okay, so let's give another parameter for shape choice. from 0 to, I don't know, 2. To the select input parameter. Okay, anything else? This value could be parameterized. This is the inner gear, or it's related to the scale, I mean thickness of the gear, but smaller the bigger, so how should I call it? Should be in between 0 to 1. Okay, anything else? Scan, Boolean, transform, yeah, this one as well. Shape, scale. In order to fit the scale, fit the geometry within the sphere. Should be in between 0 to 1 again. And that's probably it. I can also control the speed for the rotation by changing this frame value. Oops. If you want the constant speed, then you can just have it as it is, but if you want to have some smooth in and smooth out, then you can use something like ramp parameter to control the animation speed. Maybe I can drag and drop this one. And let's try to change those values. If I make this point smoother, like B-spline, B-spline, like that, you have ease in, ease out. Not so obvious, is it? Is it used? Yeah, I think it is. Let's make it a bit more obvious. How's this? Alright. Okay. So you can control the animation like that, or you could go like these. It's already rotated on the first frame. Maybe I want to make no rotations on the first frame. To do that, need to change this value to go from exact 0 to 1 value. Maybe I can divide this, I subtract this by 1 and also subtract this by 1. This animation is a bit weird. It ain't natural. Alright. And and you can always change the end frame to control the total speed. Okay, looks better. And you could always go back to any other gear choice. Oh, this is funny. Okay, I think that's pretty much it. Let me give some colors and I'll end this live. Maybe I can also have another polygon, the base polygon, like you see in here. I was using truncated icosidodecahedron, but maybe I can also add this as a parameter as well. Truncated cuboctahedron, right? Which should be easy to create. I don't know how. To me, just trimming with the cube should work. Let me see if there's a easy solutions to this. So by truncating this shape here, so you start with the cube, you create the corner triangle, then you create this square on the corner, then you get this colored faces. Now this still looks like a rectangle, so maybe in order to make this square you might need to do some operations. And maybe there's a way to, maybe if I have this shape, maybe same as I did with this soccer ball, maybe there's a way to make similar stuff using bevels and stuff. I'm not sure what's can it come from the cube? I don't know. I can just try. Oops. Nope. Nope. Yeah, I don't have wait, what was the based information? So octahedron gives you the same result. Interesting. Actually, this gives very interesting shapes. Oh well, maybe I can do the other way. I mean, the way that I was going to do for the soccer ball shape. Let's see. Yeah, this, I think this will just give you, yeah, this doesn't look like this maybe is a square. Oh, I'm not sure. Proportionally doesn't look like, but this edge length and this edge length seems equal. Maybe not. Maybe not. use the extra time to do that. For now, let me finalize this. Okay. So I'll just give a group to the side of this gear so that I can color it in different color. So the side geometry is the skin value. So and the top group is this one, and the bottom one is this one. So for each group I can give some different colors. I'll just give the side a different color. Alright, looks like a robot now. Okay, that's good. So I'll most of all the process that I wanted to show for today is done. Just want to thank you everyone who joined the live stream, who commented. Really appreciate it. Hopefully I'll be able to continue doing this from now on. Yeah. So thank you very much for joining. I'll use my extra time to go with another shape, this one. To have another parameters. Okay, I have a questions from John Doerr. I'm curious about your UE workshop. I wasn't really able to follow as my Japanese isn't tourist grade. Was it about demonstrations, collaboration? Oh, okay. So recently I posted the live stream video for the workshop that I did at school called Kyoto Institute of Technologies in Kyoto, where I did a workshop using Houdini and Unreal Engine for Fortnite UEFN to create a parametric world, custom parametric world, making the world design using Houdini and try to create some interactive system in UEFN. In Fortnite using UEFN. It was mostly it's a school project, since I'm currently working as a researcher in university, so I wanted to create one project doing this workshop for students, including people from outside the school, to experience some interesting method to create a virtual world using tools like Houdini, which I'm fond of, as well as some interesting tools like UEFN, which you can easily create multiplayer games using Unreal Engine based knowledge. So that was kind of a test for me to see how much people can grab the like idea creating their own world, virtual world, by teaching the tools from scratch. And I think it went pretty well. It was pretty interesting overall. Everybody's project was pretty outstanding. So hopefully I'll be able to continue doing that workshop per year, maybe next year as well. And hopefully I'll be able to also do it for in English instead of Japanese, so that many people could join, even outside Japan as well. But I'm not sure for that, since this is a school related project. Oh, that was that. Yeah. I'll try to create the subtitles for that videos, and maybe I need to edit that because the final review was in 10 hours. It's so long. Well, thank you for the comments. Yeah, that was one of the reasons why I couldn't post a streaming video, because I needed to prepare a lot for that workshop. Alright, what was I? I wanted to try this one. Yeah, this is obviously is not square. Let's see if what's the best way to deal with it. If I have a octagon like this, so from now on, this is just my extra time. You don't really need to follow, I guess, my try and error from this stage. So if you're interested, please keep joining. If not, yeah, you can always leave. After I finish this live stream, as always, I'm going to upload the files that I created here, so to share with you all, and so that you can go look back and see what I did in files. Yeah. Hopefully you find it interested. Let's see. So, first of all, what I wanted to do is to create a octagon, 8 corner geometries for each face. So, creating a corner, triangle corner, and this corner shape should be so this is, if the length right here corner is 1, then this should also be 1, this should also be 1, so you could guess the ratio, right? So 1 square root 2 is the length for the diagonal length if the horizontal length is equal to 1. So the ratio for each corner will be no, actually the length here should be equal to 1, but divided by square root 2. Yeah, so that will be this length here, and I need to know the ratio by dividing this by this value plus no, 0.5. 0.5. Okay, so this is the ratio for from the corner point to the half distance in order to define the point positions for the diagonal edge. Should be. Yeah, should be. Then get the neighbors. I'll just do it per primitive. Well, maybe not. It's easier to do by point. Why am I having error here? Okay. I can now get the neighbors. Get the neighbor positions. Get the half point positions, which is half of this vector value. Right now the actual point position that I want to move to is current point position to mid plus minus current point positions multiplied by this ratio, I think. Let's check. Okay, so this is the point that I got. Now that I got it, I want to connect with a triangle. So at vertex 0 poly new pt. Oops. Frame. And delete the original point. It's not correct. It does not look correct. Okay. Why is that? Yeah, this is wrong. No. I think you need to add this one right here. All right. Okay. Now, how do I make an octagon out of these? Actually, it's not that easy from here. Probably, after all, it might be better using primitive wrangle instead for each primitive. I can just copy all these stuff here. using ratio is fine instead of using neighbors. I get all the points from the primitive. Get the point number. And I also would want to get the next numbers, right? And there is a chance that the point number is not clockwise or counterclockwise, so instead of using prim points, I might better use prim vertices so that it will be assured that the order of the points is in clockwise or counterclockwise, either way. So to use this, I need to convert this into a point to get the point positions. Using vertex point, and again make sure that this goes back to 0. Alright, now I have position 1, position 2, and finally, I think I can use this ratio. Now, the mid position is position 1 plus position 2. Alright, then I need to create one new 2 points per edge. Okay, so new position 1 is position 1 plus midpoint minus position 1 multiplied by r. Yeah, position 2 is position 2 minus plus mid pos minus position 2 multiplied by r. Alright, and you have 2 new points. And then give new primitive at vertex prim new point 1 at vertex primitive new pt2. And this should be vertex vertex point. What's wrong with it? Maybe need to input the 0 first. Alright. Interesting. What the hell? Something is wrong here. Maybe I need to fuse it before. Nope. Nope. Oh, wait a minute. This is wrong. I need to remove prim. Okay, so now that I have this triangle on the corner, I can just move this octagon to 45 degrees in this direction for this one, 45 degrees to this direction for this top, so that every corner you are going to have a square on the edge. That's my plan. So to do that, you need to specify how much you need to move each polygon to each direction. Maybe you can just move to the normal directions and see how much you need to move in those directions in order to get the right value. It's just a simple mathematic, I think. So what was that? What's the conditions? So you have edge right here. Right. So you want to move each edge so that the corner will be equal to L. So you need to define how much you want to move to the vertical, to the perpendicular directions. It's pretty easy. To get the A, you need to do like that, and since I want to calculate A, that's that. And the L is the length of this edge, so it's pretty easy to define. This is, what's the length? I can just get it from the convert line. Hopefully every edge length is the same. Yup. Okay. Now I can then move each primitive to the perpendicular directions. Let's calculate the normal just in case. And this is already, maybe I can just use point, which is easier. And maybe I can calculate the vertices base normal. Should be perpendicular. Yep. Right. Now for the point, I need to get the reference length, how much I need to move from the second input. Everything is the same, so just get the first one. Then what was the equations? L divided by 2 square, L length divided by 2 square root. Then I can just move this point to the normal direction, multiply by move. Wait a minute. Is it? No. That's not. Wait, is it? No, this should be it. Wait, let me go back again. A power of A. Yeah, this should be correct. Why does it seems wrong? Doesn't look like square shape to me. Looks rectangular to me. Get the less lengths. How much is this move value? It must be at least less than lengths for sure. Is it? No. Okay, it's obviously wrong. Okay. Wait, it's just a single trigonometry, isn't it? A, right? A, right? A power of A plus A is... wait, I didn't do the power for the lengths. Shoot. Square for the lengths. Forgot to do that. There you go. Okay. My mistake. Okay, now it should be in this correct layout now that I just need to add these squares and hexagons in between. Now, to do that, I think I could fill the hole for this one. Or maybe I could just do it here within the code. Each edge, for each edge, I could create a diagonal rectangle here, probably. For this one, it's not just trying. Okay, let me add fill, polyfill to this one. Okay. And once it's being moved, the triangle shape had to go diagonally, and the amount of movement that needs to go for each triangle, is it the same as this hexagon? Maybe. I'm not sure. It's getting complex that I wanted to, but let's just test. Maybe I could just connect this here. Make this unique points. doesn't look correct. That does not look correct. Yeah, so if I move here and here, the amount that I need to move is based on, well, it's not too straightforward. Alright, I'll think of another way. What's the... Just want to think of a easy way to deal with it. Okay, got an idea. So these part, for each point on these corners, I might want to share the same attribute, like corner 1, corner 2, corner 3, and so on. So to do that, can just get the corner, and for each corners I can apply a corner number. Using XYZ distance again. Right. Okay, should give you related corner number here. Probably better in the integer. Now, going back here, if I move each point, these corner points should be preserved, and let's say if I delete the primitive, only keep the points and try to create the polygon between points using the same attribute. Now the problem is the order might be wrong, but let's check. What was the corner number? Okay, as I suspect, the order is not in the constant order, so that I need to fix. Okay, so this is where I set the corner point. Now, how would I do that? How would I do that? Okay, so let's first get the linear vertex number from the point, shall we? Point vertex. which will give you the ordered ordered vertex number for the point on the primitive. Okay, then let's also get the current primitive number. Like that. Oop, what happened? Oh, my keyboard has lost connection. Okay. Okay, so current vertex number and current primitive number, right? Now, the order, I'm going to use the order to sort the point number, so which will be C prim multiplied by it's based on the number of vertices, but I'll just give really high number and CBT. Okay, and let's see what happens. I'm going to sort the point based on this attribute that I just created. Oop, didn't work. Wait, did it really sort it out? Actually, it didn't really change anything, did it? Nope. So it was nothing. It was didn't have any meaning here. Okay, that's that. So it didn't work. Let's think about a way. So I want to go from 1, 2, 3, 4, 5, 6. Right. To get these ordered, maybe I can just calculate the angle value based on the axis to the center of this hexagonal shape. Based on these angles, I could estimate the order for sure. Yeah, which is kind of a cumbersome, but maybe that's the way. Okay, well, these are try and errors, and maybe there are some pretty easy way to do, but it's I mean, I enjoy this kind of things because I learned along these tries and errors. So get the primitive center from the second input. Okay, so I got the center, meaning I got the center, I got the axis informations. Right. Now for each corners, I need to I want to calculate the angle value. So the axis the axis is normalized value of center, was it? Actually, I need to have it as a attribute. Okay, so I have this axis value for each point. Right now, I could create a rotational matrix by using dihedral from axis to which angle is better? Let me see. From axis to top. Right. Then I'm going to have a temporal positions, which is current point positions, rotated using this rotational matrix. Set the y value to 0, then normalize it. Then calculate the angle by using a tangent 2 by using t pos z and t pos x, which should give you a value in between 0 to 2 pi or minus pi to pi. And I'm going to apply this to an attribute, then sort the point based on this angle. There you go, and make it closed. There you go. Alright, so I have hexagon, I have octagon. I can now merge it together and fuse it. Finally fill the hole. Okay, so now I have this things and this thing here, so maybe I want to have another parameter that I can change between these two base polygons, which both have even number polygons, so each one of them should work. Okay. It's funny that it's fun. Always takes more time than this one. Okay, so let's give a switch node to switch between these two polygons. Now I always forgot the name here. What's the name? Truncated cuboctahedron. Let's have that as the first parameter. Let's order the menu. Second one, second one is this one, truncated icosidodecahedron. Dodecahedron. Is people able to pronounce this? Okay. Right. And copy this parameter, paste it here. Now based on these informations, I need to also change these pair parameters, because this is related to these part. Now let's make the name more general. Let's say I'm just gonna name it as SML as the term of size. So 4 is the smallest, 6 is the middle, 4 is the small, L is the large, 6 is middle, 10 is large, which can be used for the other polygon as well. Yep. Now that's fine, but there's another conditions that I'm using these pair info, which is this one, which I'm hard coding here. So that's not good, is it? Nope. So in this case, it might be better if I have if I already have an informations for a minimum and maximum num edge, so that I can use it to see which one is in middle, which one is in the maximum, which one is in minimum. So maybe I can bring this thing up above, right here, so that I already have those informations. Wait a minute, I actually cannot use it because I'm calculating the number of edges here. So let's have this calculated beforehand. Like this. Okay. Now I should be able to get the information that I need. Yep. If it's not equal to 4, if it's not equal to 8, then it's in the middle. That's what I can assume. So now I don't need these informations anymore, and what I need is max num edge then if pair is equal to 0, which is in between S and M, so if number edge is equal to maximum, that's what you want to delete. If pair is equal to 1, which is in between S and L, so if it's in the middle, then that's what you want to remove. So it's not equal to max number edge, and it's also not equal to min num edge. And last of all, if number is not equal to min num edge, then you want to delete it, and you don't need these. Now let's see the result. Okay, so this is M and L, looks correct. S and L looks correct. S and M looks correct. If I change this to this one, S and M, yeah. S and L, yeah. M and L, okay. Everything works fine. Now let's go back to the end to check the whole shape, if everything works. M and L, S and L, S and M, truncated icosahedron. Yup, everything seems to work. And that's it for today. Yep. Pretty satisfied. And this also should work, right? Yep. Okay, that's it. Okay, so it took a lot of time to complete this, but this is it for today. Thank you for joining. I'll upload the files to a Patreon page, which is free to browse. But if you're interested in supporting me, that'll be great. I'll try to continue constantly from now on. Okay, thank you very much for watching. If you're still there, thank you for joining. I'll see you soon with some different topic. Hey. Night. Good night, everybody. I'll just add another shape and I'll finish this. Oh. Okay, I like it. This is cool. This is very fun. Okay, night. Thank you. End the stream.